Alright everybody, so welcome back, it's back to it. Last time we set up this subroutine that allows us to print out one block from the character set, and in this video we shall see if we can manage to print out the actual text line. Now, in order to do that, we set up the zero page register 2 to point to the location where we want the character to be printed or copied. And when we basically call this routine, we load the X register with the character to print. And we will actually tell the X register to read from the text line. So I'll copy that up here, which means that when we run it now, it should display the first character, which is a T, which is the capital T there. So that looks to be okay. Now, the next thing that we need to do is to, once we have done printing out that character, we need to tell him to read the next character. So in order to do that, we shall increase this one to fetch the next character, and we'll obviously set up some type of loop here. So we'll do that. Where we do it, I think we can probably do that down here. It's not very critical. But anyway, we fetch that, but and then let's make a print line loop here. And let's jump to the print line loop. Now, obviously, we have to get out of this also. So it's the next thing. We see that we have this character here, FF, which is signifying that you reached the last character of this line. So once we read this character, we shall check if it is FF. We shall tell him to complete. So that by itself should loop through and print out all the characters. So let's just see how, oops, let's see how that looks, and there we have it. And you can see it's TESTING, etc. So that looks to be correct. This is the actual text here. Now it obviously is not working how we want it to work, but at least it's cycling through the characters and printing them out. Now the problem here is that this set P register 2, which controls to the location on the screen where we want to print the characters, this gets modified down here. So this will update this pointer to go to the next line, and this thing and will try to put it on the next line and next line. Plus this also probably messes up a little bit. So we need to somehow preserve this location. So I'll write it to set P register 3. I'll use another register, which is the base position, and here we shall copy the setp register 3 to setp register 2. So basically, before we start printing anything, setp register 2 will be updated with whatever value we gave it on the top here. So if this works out, I think now the letters should be printed on top of each other. So let's see if that works. If I can manage to press the right launch buttons here. So there we go. This looks correct. And why is it looking correct? Well, it's a 1, which is actually the last character. And before the last character, it's a hash, which you can see part of here. The reason why you can see part of this one is the 1 is printed on top of the hash, but the 1 is only 2 characters wide, which you can see here. And the hash is 3 characters wide. So that means it's actually evidence that the differential width works as it should as well. So that is fine. But obviously we don't want the letters to be printed on top of each other. We want them to get spaced out towards the line or throughout the line. Now, what we're going to have to do then is to update this setp register 3, which is the base address for where things should be printed. And once we have completed printing the block, we can, for example, increase the setp register 3 with the width of the char that we just printed. So let's see, we can start by adding just 3 lines just to see that it actually works out, not make it variable, but let's put it fixed 3 lines. So I'll fetch, let's put it to the right register. So I'm going to put it to 18, that should be 3 blocks over. And increase the high one if we cross the boundary. And let's store that. There. Now, if this works as I hope, we shall get the letters printed out with a fixed distance of 3 characters. Holy moly. So there we go. And there we have it. It actually looks to be working fine. Now we can see that the T looks okay, the E is okay, but the E should only be 2 wide, so the S should be drawn 1 earlier, the I 1 earlier, the N 2 earlier, etc. So we need to find out, and once we draw the 1 here, it overflows, so it starts actually drawing on the next line down here. That's expected. But once we add the variable width of this, it should be fine. Now, the question or the issue then is this one here. Shall we add 8, 10, or 18, or even later for the bigger characters, 20 or 28? And this will depend on the width that we read down here. In the width table, let's see, the width table, we are reading that here. And that's what we use to determine the width that shall be printed out. But this value is not, we cannot use this value, so we actually need to make another table. Let's call it width table 3. And this time we shall use 8, 10, 18, 20, and 28. That looks about right. and let's call it width table 3 and put this to 0 temp 2. I'm not sure if I have that defined. Let me see. No, I don't. So let's go and add it, shall we? Zero page, there we go. So we have a 0 page temp here. We'll just add this as 0 page temp 2. That's what we call it, I believe. Yeah. So see that it starts, yes. So that's fine. Just gave ourselves another 0 page location to play with. Now, basically then, instead of add carry with 18 here, we should use the 0 page value instead. And let's see if that actually does something useful. And it does. It actually looks to be working perfectly. So now we have the T 3 wide, the E 2 wide, the I 1 wide, space 1 wide. It looks to be working perfectly. So there you have it. You have now actually managed to print out a line. Now, the next thing that will be the issue is actually to center this. And I believe we did that. We calculated this before with this code here, which actually reads the pointer and takes the width, subtract the width of the letters and divide it by 2, which gives us the offset. So that should basically work, and then we can add that offset to setp register 3 up here. So that should shift this to the location it should be on the screen in order to make it a center as we can get it. Let's see if we can't just simply steal this one. So we'll remove those, the online width table, width that is a variable. So let's call this to setp temp. We'll just use that. It's a little bit easier. Text pointer and jump count line 1. Is that on top? Yes, it is. So count line. That should be okay. Down line. Move it. Yeah, this you don't need. Because we're not going to loop through this, we're just going to print it once and done. So then 40, subtract that, and then store that in offset of the line. Actually, I think we're going to do this one on top here. So this will point us to the correct line. And A then contains the offset. So basically what we need to do then is multiply A with 8, because it's 8 bytes in each shift to in the horizontal line, and add that to 0 page register 3. Now, actually what we're gonna do, we're not going to use 0 page temp. We're going to use 0 page register 1 low. Low. Now also we should make sure it's 0 before we start here. So text line on with set p ratio 1 low and logical shift right. Good. Okay. Instead of doing it like that, there. So set p register 1 low now should contain the offset that we need. And then we need to multiply that with 8. So we'll shift it left 3 times. We might get away with deleting these two, but I'm not sure if that could cause an error, because if we shift it, that actually removes some of this info. We can test that to see, but now we also need to make sure, I don't think it's gonna be an issue, but in case it's overflowing, which if it's, let's say, 40 multiplied with 8, so it could theoretically overflow. So let's just do that as well. So this is basically a 16-bit multiplication of whatever figure is there. And then we just need to add that to the 0 page register 3. I really should write a 16-bit add carry also, would save us some time here. So 0 page register 1 low, and we will store that to register 3. Now the carry should take care of any overflow here in this edition. So that should be it. Okay. Now this is probably gonna look horrible, but let's see what happens. SMC text pointer. Oh, okay. Let's call it counter. There. That didn't work at all, did it? So we zero out. First we put it to the actual line where we want it to be printed, which is from line number 5. We read the text line, check if it's done, fetch the width, and add it to the 0 page register 1 low byte. And then we increase the counter, and then we, here we go. That should not be inside there. Neither should that. So let's do that. This should be outside. So overhead setup. Okay, so maybe that fixed it. Yeah, well, at least it prints correctly, but there was no offset added. So let's take a look again. Add that to the low. That should never overflow, so it's no point to do anything else with that. And count the line again. 40 is a bit much. 28. Doesn't make any difference though, but still that's not correct. Could put it in hex 40, that maybe make more sense. So I think till here at least this looks to be correct. And that is basically dividing it by 2. So 40 minus the width, and the result, no. And store it there, and then divide it. Well, there we are at least one step further. It at least offsets now. Not with the right figure, but can have everything. Two, 4, 8. Let's just take out this bulk here and see. That means that it should take all the space and it should right align it. Let's see if that is even close. Oh no, dear Lord, no. Let's see. So let's force it. Let's put 5 space, 5 block space. Let's just force it, store that to red 1 low. See what that does. Looks to be working correctly. Zero. And 1. Yes, so the offset seems to be working. So this part here works fine. So basically there's something messed up here. Let's try and store it as well. See what that does. Well, that adds too much. With table, it is the correct one. Yes, it's that. So, read the text line. Check if it's FF. If it's FF, get out. Ah, sorry, I'm in the wrong place now. Moron. So read the, let's not compare it, but let's compare it with X. So I was comparing A, not X. And there it is, centered. So that's coding for you. It's always easy to do small mistakes like that, and the really difficult part is figuring it out afterwards. But this looks to be working correctly now. We have the routine to print a line with the variable width font and automatically center it. So I'm good with that. I'm going to do one little test just to see if that makes any difference at all. it's exactly the same, which I would expect it to be. So there's no point to the only thing that will happen is that if you have a odd number, not a pair number but the odd number, so let's say the space is 5, you divide it by 2, it will be shifted. Let's see, so 1, 2, 4, so you'll have a 1 and a 0, 0 and a 1. So this is 5 in binary. If you divide this by 2 by doing a shift, it's going to look like that. And then you multiply it with 8. So here you divide by 2, and this is multiplied with 8. This is the result you're going to get. If the starting number is 5. Now, if you skip that step there, that will disappear, which means you're going to be bringing with you this bit. So instead of let's see, 8, 16, 32, you're going to have 34. Sorry, 30, 1, 2, 4, 36, yeah. Which is not correct, because 36, it should be in a multiple of 8. So actually, I do think we're going to need it, because this is 32, this is 4, 36 total. And if you add 36, it's not going to be aligned properly. So if you get an odd number where this bit is set, you need to get rid of this bit. So we'll keep it. Not that it really matters much anyway. And we'll call that a day. So there we have it. We do not need this anymore. We don't need that anymore. And this takes care of it. And our subroutine, that's good. The only thing that remains now is handling the special characters, the 4 and 5 block wide characters. If I, for example, we can do a quick test. We'll call it not testing, but West Ming, just to see. And we can see the spacing is correct. The W is, but it doesn't draw these two blocks here and there. So obviously that is something that we need to take care of. But that will be in the next round. So we'll add that. We'll handle that by just doing some simple checks. So we'll check specifically for these 3 characters that this is regarding. And then we'll write some custom code to handle this. And once that is done, we will take the final routine and we will bring it with us back into the main program. And then we should be able to write out some lines here. And then finally what we'll do after that is just add some color fading or something to actually show this. And then we should be pretty much done. The only thing that remains then is to find some music. That I said I will just use some of this copy-free music that is in YouTube to make it not only look a little cool but sound a little cool, and then hopefully that should be done, and we can start pumping out some of these other videos for that channel as well. But we also need to make the up scroll for the end part, so that's also something that we're gonna do. But first we need to finish this, and hopefully next time we should be able to get the text into this part here. So that's it for today. Thanks very much for watching, and I hope you find it interesting. It's a little cool to see maybe some of the actual troubleshooting, and also I'm sure a lot of you spotted the compare instead of the CPX, for those of you who are familiar with this programming, and started tearing your hair out, but it is how it is. So it's very easy to write a small mistake, and it's going to take some time to figure it out. But anyway, take care, happy coding, and see you next time.